Hello students, I'm Sonali Kelkar from City International School and today we are going to do a new chapter on physics. As you can see on your screen, that is gravitation, right? And the topics that we are going to cover in gravitation are gravitation, then what do you mean by gravitation, then universal law of gravitation, force of gravitation of earth, that is called gravity, acceleration due to gravity, that is represented by small g, free fall of an object, mass and weight, then weight of an object on the surface of moon. So let's start the chapter. Now looking at the picture, you can see that a person is sitting under the tree and there is an apple falling down right in front of him. So of course, by looking at the picture, apple and a person, you can make out he is none other than Isaac Newton. So he was observing the things around him, and if you know that, before that, in the previous chapter, we have learned about the motions and then we have learned about the causes of motion. Newton has given all the three laws of force that strike into his mind that if the apple is falling down, he won't fall down by its own. There must be something which is acting on the apple, that is nothing but the force of attraction. So it was a force which was changing the direction of the motion. It was the force which makes the body move when it was in rest. So definitely then there is a force acting on the apple. Okay, so he found out that yes, the force which is acting on the apple or on any other object on the earth is known as the gravitational force of the earth. The force with which the earth pulls an object towards the center is called the gravitational force of the earth or the gravity of earth. Now after that, few more questions were there in his mind. So let's see the questions first. Why does apple fall on the earth from the tree? He knows that this is due to the gravitation force of the earth. Can apple attract the earth? Okay, so he was telling if the earth is attracting an apple, okay, so is there any force which is acting by the apple on the earth? Does apple also attracts the earth? Because he was the one who gave the Newton's third law, action, every action has equal and opposite reaction. So it was there in his mind. And yes, on the basis of Newton's third law, we can also say that if the earth is acting force on an apple will also going to exert force on the earth. So okay, so this answer also he found out. Now coming to the next. Okay, if the earth can attract an apple, can it not attract the moon? And if the earth is attracting an apple, can it not attract the moon? So he has to find this answer also, right? Later on, he came to the conclusion that all the objects in this universe attract each other. Newton suggested that all the objects in this universe attract each other, and this force of attraction is called gravitational force. So children, there is a difference between the gravitational force and the gravitational force of the earth, which we also call gravity, simple gravity or the gravity of earth. So he came to know about these type of two forces which are acting on all the object which is there on the earth, right? And the object which is on the earth is definitely the gravitational force by the earth. Now let's find out the answer of his different question, right? Here we know that because of the gravitational force of the earth, apple is falling on the earth. But what happened if the apple is also exerting force on the earth. So let's find out. Okay, according to the Newton's second law, where force is equals to mass into acceleration, right? So I want to find out the acceleration, okay, because due to the acceleration, because of the motion, acceleration will be formed, right? So let's find out the accelerations. Acceleration is force upon mass. So here we came to know if the mass is more, acceleration will be less. Why? Because acceleration and mass, they are inversely proportional. Acceleration and mass, they are inversely proportional. Now what do you mean by inversely proportional? Means if one quantity increases, if the acceleration increases, then the mass will be less, right? So this is what the case of apple falling on the earth. Apple has very small mass, right? Mass is small, very small mass as compared to earth, right? So mass is small. That is why the acceleration is more. It is falling with a great acceleration, right? The apple is falling towards the earth with the acceleration due to gravity, right? This is falling towards the earth with the acceleration of gravity. But what happened when apple pulls earth? As we know that according to the Newton's second law, apple is also going to exert force on the earth as the force of the earth is exerting on apple. Now let's find out. So looking at this, if I increase the mass, if the mass is increased, okay, if the mass is increased, definitely the acceleration will decrease, because mass and acceleration are inversely proportional to each other. So if you can imagine how huge is the mass of earth as compared to the apple. So definitely the surface is moving, but you cannot imagine how much it is moving. It is negligible, okay, it's completely negligible, because mass is too huge and acceleration will be too less, right children? So he found out his answers, right? Note, the gravity is one of the most basic force in the universe. It plays a fundamental role not only in the structure of our solar system, but also in the way objects behaves on earth. So let's see how the gravity affects our solar system. Now here Newton even thought of this question: if moon is attracted by earth, why it does not fall towards it, right? He concluded that all the objects in the universe, they attract each other. So definitely the earth attracts moon, moon attracts earth, earth is attracted by sun, sun is also attracted by earth. All the planets which are revolving around the moon, they also attract each other, as well as they are attracted by sun also. Then why can't they collide with each other? There can be a collision, right? If a sun, okay, and earth, or let's say other planet is moving around, and there is a force of attraction between the sun and the earth, just like the apple, why can't the earth just come and collide with sun, just like an apple? Okay, if there is a force of attraction, right? He has already told that there is a force of attraction, then there must be some other force also which are acting on the earth, okay, or let's say on the moon. Okay, if there is earth here, right, this is my earth and this is a small moon, right? And why this moon is not coming and colliding to earth? Why it is not coming like this? Okay, why it is not colliding? Why it is moving around the earth? So there must be some other force which is making moon to move around the earth. So let's find out what is that. Okay, so he conjectured conjectured that the nature of the force is same whether it is moon or earth, and the earth attracts all bodies, right? Now the force is there when, now as the force is there, then why there is no acceleration? Well, there is an acceleration called centripetal acceleration, right? There is an acceleration. How can we say there is an acceleration? Because when anything like here moon is moving around the earth. When a moon is moving around the earth, you can see that at every instance the velocity is changing. Why velocity is changing? Because at every instance the direction is changing. At every instance the direction is changing. Here the direction is like this, right? Here the direction is like this. Every instance the direction is changing. Okay, so due to the change in direction there is a change in velocity, and due to the change in velocity there is a acceleration. And what type of acceleration is this? This is a centripetal acceleration, and the force which cause this term, the force due to which this acceleration is producing, that is called a centripetal force. Now this centripetal force making moon to move in a circular orbit. So this centripetal force is acting towards the center of the earth, from the center of the moon towards the center of the earth. This centripetal force is also known as central seeking force. Central let me just central seeking force. Centripetal means central seeking, children. Okay, so this is central seeking force. It seeks, it's find, seeking force. Centripetal is a central seeking force, so it is acting towards the center of the earth, and because of this centripetal force the moon is moving around the earth. So this is all about centripetal force, but there is one more force, and this centripetal force is due to the gravitational force. Here the motion of the moon around the earth is due to the centripetal force, and the centripetal force is provided by the gravitational force. The centripetal force is provided by the gravitational force of attraction of earth. So here we came to know that yes, even the force is acting between the two heavenly objects, and due to this force the moon is moving towards the earth. But have you ever observed a boy, okay, tied a stone with a thread, and it is moving, and this boy is moving this stone round and round and round in a circle, right? So as soon as, or at any point he leaves this thread, what will happen? Wherever he leave the thread, this particular object will go straight forward. It will go forward, straight forward, right? But why can't the moon is going straight forward? What is the other force which is acting on the moon, which is making moon to move in a same path? Okay, so moon also can leave the path and go anywhere else straight. It can move anywhere else. So there is a one more force which is balancing this force, right? The moon is not coming towards the earth and colliding with the earth, because there is a force which is just opposite to of centripetal force, which we call centrifugal force. Okay, children, so these forces get balanced. Centripetal force is acting towards the center of the earth, and centrifugal force is acting outside the center of the earth, or away from the center of the earth. So due to these two forces, this moon is moving or revolving around the earth, and hence all the planet moves around the sun. So this is what is the reason behind why the moon and the earth are not colliding with each other, or let's say other planets are not colliding with sun. Yes. Now what is the centripetal force? We have already discussed here. The centripetal force is acting towards the center of the earth, right? And due to this centripetal force, this object is moving around the earth, right? So this is nothing but moon is moving around the earth. And why it is not colliding? Because there is one other force which is just opposite of centripetal force. So these two forces balance each other, and due to this balanced force, the moon is moving with a uniform velocity around the earth. Now what is the universal law of gravitation? As you can see in this picture, my God, every object is attracting towards each other. Everything is attracting towards each other. As I have already told you that the force of attraction among all the objects in the universe is nothing but the universal gravitational force. And what Newton did? Newton found out a formula for the universal law of gravitation. And what is the formula? Right, before we come to the formula, before we derive the formula, let's see the different points given in universal law of attraction. It says that all objects attract, all objects attract all other objects. As you can see in this picture, all objects attract other objects. You can see in this picture, every object is attracting each other, right? The force of attraction is proportional to the product of their masses, right? The force with which they are attracted towards each other, it is proportional to the product. That means the product means multiplication, right? So the product of their masses, when you multiply the masses of these two objects, any two objects, okay, so that means the force is proportional to the product of the masses, and inversely proportional. As I've told you, what do you mean by inversely proportional? If one quantity increase, the other will decrease. So this is what the inversely proportional, right? And inversely proportional to square of the distance between them, right? And the force is along the line joining the center of the two objects. Now what do we mean by the line joining the center of the two objects? So let me explain you with the help of a diagram. Suppose this is my earth and this is moon. Now this is the center of the earth and this is the center of the moon, and the force is along the line joining the center of these two objects. So this is a line which is joining the center of the two objects, and this is what a distance we are going to consider. Okay, when we formulate the equation, the formula, when we derive the formula, that time we have the distance is nothing but the distance between the center of the two objects. So you must know the center of the two objects, and the distance between the center of the two objects is considered in the formula. So let's derive the formula. Okay, so universal law of gravitation of Newton. According to the universal law of gravitation, every object attract each other with a force. So this is what is stated in universal law of gravitation. Every object attract each other with a force. And this law, because it is a universal law, that means it is applied to each and every object in the universe or on the earth, right children? So this force is directly proportional to the product of the masses we have done. So let's take the masses. Okay, this is the object 1 here and object 2, right? The mass of the object 1 is considered as m1 and the mass of the object 2 is considered as m2, right? So m1 mass of object 1, m2 mass of object 2, children, right? And the force, now this is the force which is acting. As you can see, this force is acting on two different bodies or on two different objects, right? And you can see that these forces are opposite in direction, right? So definitely the equal and opposite force are acting on each and every object in the earth, on the earth or in the universe. Even between the computer and between me, between the books and between any other object which has mass, any object which has mass, they attract each other with a force which is equal and opposite. Clear? Here the distance we have considered is taken right from the center of this object, object 1, and the center of the other object. So D is the distance between their center. And what is G? The capital G is a gravitational constant. So we have to take the gravitational constant, and the value of the gravitational constant is 6.673 into 10 to the power minus 11 Newton meter square per kg minus 2. How we are going to derive this, we are going to discuss in our next slide. Right, here we have already known that there is a force, right, which is proportional to the mass m1. So that is why we have taken the force proportional to the mass m, and the force is also proportional to the mass of the object 2, right? And the force is also proportional to, inversely proportional to the square of the distance, right? Here children, the distance is taken as small r. The distance between these two objects is taken as small r. So distance over here is denoted by r, right children? And why we have taken r? Because it's a distance from the center of this object and the center of this object, right? So we are considering the radius and the rest of the distance also. That's why we have taken r. You can take any other alphabet also, but usually we take r, right? So from the above equation, so we can rewrite them as follows. When we will join these equations, right? When we will join these equations, what you will find that the force is proportional to the mass as well as the force is proportional to the mass of the other object. So force is proportional to the product of the mass of the two objects, right? So product is m1 into m2. I don't have to put a multiplication sign here. Even if I write like this, it is by default that they are multiplying with each other, and the force is inversely proportional to the square of the distance between them. Now if the distance is r, then the square of the distance definitely will be r square, right? Okay, so this is what we got in the fourth step. But if I have to remove this proportion, okay, I need to remove this proportion by introducing one constant, right? So by introducing the constant, I need to remove this proportional sign. Okay, so what is the constant is? So we see that this constant is capital G, which is known as gravitational constant, right? So I will replace this sign of proportion with is equals to sign, and I will introduce a capital G, which is nothing but the gravitational constant. And the value of the gravitational constant is 6.673 into 10 to the power minus 11. Now let's find out the unit. How we found out the unit? To find out the unit, I must know the formula of G, right? So you have to keep this G on your, let's keep the G over here, right? Or I will flip the equation. I'll keep G m1 into m2 divided by r square. R is nothing but the distance, children, and this is f, right? So because I want to find out the formula of G, right? I want to find out the formula of G. So I'm going to keep my G here and the rest of the thing, and this is capital G, and the rest of the thing will go on the other side of is equals to sign. As you know that if I take this fraction on the other side of this is equals to sign, which is nothing but a magical bridge, the fraction will get reciprocate. So what will I get is r square upon m1 into m2. Now substitute m1 into m2, right? Now substitute the values of these signs, right? We know that distance is measured in meter, right? So meter and r square, so it should be meter into meter. So can I write m square meter square, right? Now if I substitute the SI unit of these quantities, I will get the unit of capital G, right? So meter into meter, meter square, and mass is measured in kg. What is the SI unit of mass? That is kg. So mass of object 1 and mass of object 2, that is kg into kg. So what am I getting? Okay, the force, okay, we forgot to write the force. Force is here, right? So force is here, and what is the unit of force? We all know the unit of force. So let me introduce the unit of force here. The unit of force is Newton, right? Unit of force is Newton. So Newton is at the top, at the numerator. So kg into kg is kg square. So ultimately what am I getting is Newton meter square dot kg. Even if you don't want to put dot, it's okay. And kg minus 2, because kg into kg is nothing but kg square. I can write kg square also, kg whole square, right children? So this is kg whole square, right? So when it comes up, we know that when this exponent will come up, what will happen? It will change into negative sign. So Newton meter square dot kg minus 2. This is very important. This is very important. The formula is very important. The formula, universal gravitational law formula is very important. Universal law of gravitational formula is very important, and the unit of capital G is very important, as well as the value of capital G is very important. Here I want to tell you one thing, children. The value of G, that is 6.673 into 10 to the power minus 11, which is very small. Okay, it was found out by Henry Cavendish. It is not found out by Newton's, but it was found out by Henry Cavendish. Importance of universal law of gravitation. Now what is the importance of universal law of gravitation? As you can see in the picture, see there is a force acting on the moon by the earth, and moon is also acting a force on earth, right? So definitely when there is a attraction between the earth and the moon, or let's say between the earth and sun as well as moon, there will be definitely some effect on the earth which is quite visible, right? So let's see what is it. The force that bind us to earth, right? So due to the universal law of gravitation, we are standing on the earth. This is the force which bind us to earth. Then the motion of the moon around the earth. Yes, that is also a reason behind the motion of the moon around the earth, right? Or the motion of the planets around the sun. So these all are the effects or the importance of universal law of gravitation. Then very important point, the tides. Have you seen the high tide and low tide in the oceans or in the sea? This is due to the attraction or gravitational attraction of moon and the sun. So these are the importance of universal law of gravitation. Now let's see the question, children. What is the universal law of gravitation state? Now Universal law of gravitation, a simple equation but devastating effect. Yes, it is very simple, but the effect is very different. It's very effective. The equation says that the force between the two objects proportional to the product of their masses and divided by or inversely proportional to the square of the distance between them. Right, children? Then coming to the question number 2. Why is G, this is capital G, okay, called the universal gravitational constant? The capital G is called universal gravitational constant because it is independent of the nature and sizes of bodies, the space where they are kept, and at the time at which the force is considered. So that is why it is said to be a universal gravitational constant. It doesn't depend upon the nature or the size of the body. We are using this universal gravitational constant even to find out the gravitational force between the book and between me, or between the computer or the laptop, and between me, between you and your pen, or between your pen and the pencil. Okay, so we can use this constant, gravitational constant, in this formula. Okay, so who formulated the universal law of gravitation? Isaac Newton, Sir Isaac Newton. How is the gravitation different from gravity? Very, very important and conceptual question. Now, what is the difference between the gravity and the gravitation force? Children, the force which is exerted by the earth on any other object on the earth or near to earth is called gravity, whereas the gravitation is the force of attraction between the two bodies. Okay, it can be the force of attraction between the two bodies. To the second question, next question, what does a small value of G indicate? Yes, we know that a small value of G indicate that the force of gravitational attraction between the two ordinary size object is very weak, very weak. Now let's see how, right? We know that the force of gravitational attraction is equals to G into mass, product of the mass of the two objects divided by the square of the distance between them, right? Now if I consider the value of G, okay, let's not consider these two masses which are ordinary size object. Let's take between mass of the laptop and the book in front of me, right? Ordinary size object, or let's say the mass of the two person, right? So if I consider the value of G, which is 6.67 into 10 to the power minus 11. Now children, this is very, very, very small value. When you multiply this whole with G, definitely the answer, the force of attraction that you will be getting will be very, very low, right? So that is why, that is the reason we cannot able to feel the attraction, because according to the Newton's, every object which has mass, everything which is present at your house right now, table, chair, they can experience the force of attraction. There is always a force of attraction between these objects, but this force of attraction is quite negligible. We cannot see that these things are moving on their own, right? So that is what the reason, because the force of attraction is so much less that we cannot find these type of attraction between the objects around us. But when we take Earth or Mars, Earth or Mars, right, or Earth or Sun, right, the mass of Earth and Sun is huge, is massive, and that is why we can see the different type of effects of the gravitational pull of Sun towards Earth or Moon towards Earth. Just now we did high tides, right? So these are all the effects, okay, which can produced by the gravitational pull of the object which have massive mass. Coming to the next question, find the gravitational force between an object of 2 kg mass placed on its surface. given mass of the earth is 6.6 into 10 to the power 24 kg and the radius of the earth is 6.4 into 10 to the power 6. This should be in meter, children, meter, right? So let's find out what formula we are going to use, because we have to find out the gravitational force. So the formula of gravitational force is F is equals to G m1 into m2 divided by the distance will be considered as the radius of the earth, square of the distance, right? Square of the distance. I'll explain you why I have considered the radius of the earth. Okay, now in the given, I forgot to write given. First we are supposed to write given. So in the given, they have given the mass of the object that I will consider as m2, that is 2 kg. Then mass of the earth I am going to consider as m1, that is 6 into 10 to the power 24 kg, and the radius of the earth. Okay, let me draw a radius. See, radius of the earth, right? Now what is the distance between the object? Let's take a gravitational for 2 kg mass object. Suppose an object is placed over here, right? Now what do I take the distance? I take the distance that is from the center of the two object, right? From the center of the two objects, this distance is considered as r, or let's consider as d, right? Here the object is on the surface of the earth. So distance definitely has to be the radius of the earth, isn't it? This should be the radius of the earth. That is why they have given the radius of the earth, and we have considered that the radius of the earth is the distance between the center of the two objects. The one is the object which is placed on the earth, the other one is the earth itself. So let's find out the answer. We know that value of G is 6 into 6.67 into 10 to the power minus 11. Then you have to multiply with mass of the earth, 6 into 10 to the power 24, then into 2, mass of an object, divided by radius. This is 6.4 into 10 to the power 6, because this is r square, so I have to take the whole as 2 square, right? So you will get all this thing, 6.67 into 10 to the power 11 into 6 into 10 to the power 24 into 2 divided by, you have to square it, and when you square it, the answer that you are going to get will be, so here I am getting 6.64 into 6.64, which is coming 40.96 into 10 to the power, now 6 into 2 you have to do, that is 12. Okay. And when you solve this whole thing, you are getting 19.5 Newton. So 19.5 Newton is the final answer of this question. Children, this is all about today's session. So practice today's topic. Thank you so much.